Hello everyone, we are from Batch 9. My name is Shweta and my teammates are Mahit and Karthik. Our project title is Smart Weather Monitoring Using Edge Computing. Introduction. This project is developed to monitor important weather parameters in real time using IoT sensors and edge computing technology. Weather monitoring is the process of measuring environmental conditions such as temperature, humidity, atmospheric pressure, rainfall, and air quality. As we all know, accurate weather information is important for agriculture, health, transportation, and daily activities. The main idea behind this project is to build a low-cost weather monitoring system that can collect weather data locally and processed using a microcontroller like Arduino. Traditional weather monitoring systems are expensive and they are usually used only in one meteorological stations. With the growth of IoT technology, low-cost embedded systems can now provide real-time weather monitoring using sensors and wireless communication. In our project, multiple sensors are used which are connected to Arduino controller to continuously monitor the weather conditions and provide live weather data using web-based interface. Now, coming to the objective of our project. The first objective is to design and develop a real-time IoT-based weather monitoring system. The second objective is to monitor multiple weather parameters such as temperature, humidity, atmospheric pressure, rainfall, and air quality using different sensors. Another objective is to display live weather data using a web-based dashboard so that users can easily access the readings through their mobile phone or their laptop. We also aim to eliminate the dependency on third-party cloud platforms because cloud services may increase cost and they require continuous internet access. Finally, our goal is to provide cost-effective and scalable solution that can be used for local weather monitoring. Now, let us discuss problem statement of our project. Existing weather monitoring systems are very expensive and they require dedicated equipments or instruments which will make them unsuitable for small organizations, educational institutions, or small local users. Another issue is manual observation of weather conditions. Observing the weather conditions manually is very time consuming and it will not provide instant updates on the weather conditions. Many IoT weather systems presently depend on cloud services for storing and displaying the data. Because of this, the internet connectivity becomes compulsory and it will also increase the operational cost. In addition, some existing systems monitor only limited parameters instead of providing complete weather information one systems, which is monitoring multiple weather parameters in one system is limited in many current existing solutions. So there is a clear and strong need for a low-cost system that can monitor multiple weather parameters continuously in real time and works locally without depending on any third-party cloud platforms. The next part will be continued by my teammate.
Good afternoon, everyone. My name is Maitsai Krishna and my roll number is 161. I'll be continuing the presentation from the literature survey. So let us take a look. Literature survey. Several researchers have developed IoT-based weather monitoring systems. Most systems use cloud platforms for data storage and visualization. Cloud-based systems include increase in cost, require continuous internet, raise data privacy concerns. Many systems monitor only limited parameters like temperature and humidity. Very few systems focus on local web-based dashboards without cloud dependency. So there is a need for a low-cost cloud-independent and multi-parameter weather monitoring system. Let us take a look at the literature survey table. Here is a table which is a comparison of the weather monitoring systems done by the other authors. So these are the existing product details. So here are the fields included are author and their year, parameters monitored in their project, and the limitations of that project. So let us take a look. A. Kumar in the year 2020 built a weather monitoring system with where the parameters he could included are temperature and humidity only. So he is limited to only two parameters. For our Sharma project in the year 2019, he could only include atmospheric pressure as a parameter. So there is no humidity and temperature monitoring. M. Singh in the year 2021 created a model where he included temperature, humidity, and rainfall, but it is a cloud dependent model. For P. Varma 2018 model, he also included atmospheric pressure only, so which is basically a simple parameter monitoring. And the last one, S. Reddy in the year 2022, he only monitored air quality, so there is a no weather parameter integration in his model. So if you take a look at the existing systems and its drawbacks, they include traditional weather stations, cloud-based IoT systems, and manual monitoring. These methods are costly, internet dependent, and do not always provide real-time and easily accessible data. So what are the drawbacks? Here are the drawbacks. High cost, needs continuous internet, data privacy issues, not easy to modify or expand, limited access for common users. So these are the drawbacks for the existing system. And the rest of the presentation will be continued by Karthik. Over to you, Karthik.
Hello everyone, my name is Karthik and my roll number is 98. Now I will explain the proposed methodology. In our system, multiple sensors collect data like temperature, humidity, pressure, rainfall, and air quality. All sensors are connected to Arduino Uno R4 Wi-Fi, which process the data in real time. Since it has built-in Wi-Fi, no extra module is needed. The processed data is then sent to a local web server. Users can view live data on a dashboard using any device connected to the same network. This makes the system simple, cost effective, and cloud independent. This block diagram shows the working of our system. Sensors are used to collect the environmental data and send it to the Arduino Uno R4 Wi-Fi controller. The Arduino process the data and transmit it using Wi-Fi. Finally, the data is displayed on a web dashboard in real time. So the flow is like first sensors collect the data from environment, then processing is done by the Arduino Uno. Then it uses to transmit the data using a Wi-Fi module to a web browser. Then the user can see the data in real time in a web dashboard. Now coming to the results, our system successfully monitored all weather parameters in real time. The data was processed without delay and displayed on both mobile and laptop. The dashboard updated continuously and also showed graphical data. All over, the system worked efficiently without any cloud platform. This is how the dashboard output looks like. It shows the live sensor values clearly along with the graphs. Users can easily monitor all the parameters from any device connected to the same Wi-Fi network. Thank you.